and you'll see a bunch of lines. There are things, Zeta, let's go with film 3, just go ahead if you don't mind. Is it on? Okay, clever girl. All right. On the maps, you'll see a bunch of lines like contour lines. These are isobar lines. An isobar line shows areas of equal pressure. 1013, 102, I don't know, I'm going to go high. 1020, 1030. They're like contours on a map. You know what a contour is. We looked at maps with the same type of lines. They are called isolines. ISO. And they show, and you'll see them on the map. Can you just pick out, who can pick out an isoline and tell me what pressure it is? Pick out an isoline. Isoline. Come on. Give me one. 976, okay. Which map is that? Yeah, okay. And all over where that isoline is pressure 976. It's a low pressure line, right? Okay. All right, you'll see fronts on those maps. You'll see the different types of fronts. You'll see cold fronts. You'll see warm fronts. You'll see an occluded front. Now here's something else I think I see on one of them. I purposely, yes, on this map. Hold it, hold it, hold it. I see it. You see these little lines on this map? Look at your maps. You see these little lines? Okay. Let's don't get too happy. I want seriousness here. It's a trough. T-R-O-U-G-H. What that is, a trough is out by itself. Here's low pressure. There's a line of low pressure, all by itself. And so you'll see it does like this. It kind of is a little depression of low pressure. It's between two, say between a high and a low. And a little low pressure line is a trough. That is also, it's not a front, it's just a straight line low pressure area that often brings rain. So you see that on where you have the four maps, you see these little dotted lines, that's a trough. So I'm going to ask you to identify these. So it's good to have drill. In fact, I'm going to walk around. What is this? What is it? Where's the sign-in sheet? Is it all done? I have leaves. Alrighty. Okay. So now we get to the fun part. So we have the high pressure lines, the low pressure lines. What makes wind? So what happens? What's going to happen here? All right. What's this going to do? These are shark's teeth. Sorry, triangles. All right, cold front coming in. Warm front here. What does a cold front, once it hits a warm front, what does it do? Okay, well, okay, it's a bulldozer. It's a bully. It pushes the warm air up. That's why you have rain when a cold front comes in. And dissipates the cold front, and there you go. Warm air always rises when it meets a cold front. All right? When a warm front comes in, how am I doing on time on the third one?
You're at 3 minutes.
3 minutes, thanks, Data. Okay. When a cold front is the aggressor, warm front is the aggressor, warm fronts are weak. Okay? They're weaker than a cold front. So if a cold front meets a warm front meets a cold front, like this, and then they collide, not a zipper, not an occluded front, again, a stationary front. It'll look like this. And in the stationary front, what happens? Anybody? Stationary front, what happens? What happens? Stand still. And if you stand still in a stationary front, you always get what? Rain. Never fails. Stationary fronts are rain. The warm air is too weak to push the cold air. The cold air is just kind of not being pushed, but it's just kind of hanging out doing its thing. So it's, guys, only listen. So what happens is the warm front goes over the cold front, meets it up, and it rains, and it could be that way for days. And yes?
So rain happens whenever a cold front meets a warm front and like the other way around, or like?
Yeah, pretty much, Bradley, yeah. Always, I guarantee it, unless the warm front and no cold front around comes in, and a warm front by itself also can produce rain. Because it's a warm front and air rises, but the faster way for rain to happen is when a cold front comes in. This is why I wanted to empty a Trouse up here. Anyhow, he's not here, so you're stuck with me. All right, let's stop that one, Zeta. Go on to